Guys, Josh and I are here to talk to you about the Fire Response and Environmental Protection System. We are Team Breakroom. So our overall system that we've decided to develop today is an all-in-one inclusive fire detection and analytical response package. An all-in-one inclusive everything. Once you get to the site, it will start collecting data, things that you need, things like your temperature, humidity, gas, what's in the air, everything that you might need on the spot to know. What these are going to be are devices that could be, maybe they're firefighters, maybe they could be standalone devices, or they could even be drones. Now these things, we don't have them today because they cost a lot of money, like thousands of dollars. Other people are developing much better things for us to be using. So what we've developed over the past weekend is the mock-up for a software package to include all this. I'm going to let Josh take it from here.
Oh, there's other things.
Yeah.
I didn't make that bullet points. Okay, so the fire cloud. So what we've developed in the past day is we're trying to develop a standard for how these devices are going to talk. So there's no way in hell we're going to be able to develop all of these devices, and especially now with companies like Motorola competing in this industry as well, they're going to make so much better stuff than we can do. But however, what needs to happen is all these devices need to work together. Otherwise, we're going to have a problem in the future where you have to have a complete Motorola solution. What if my fire engine has Motorola devices, your fire engine has Google devices or whoever it is? Both now can't work together. However, if there's a standard for everything to talk as one, then everyone can just work together seamlessly. So what we've developed is an API layer, and we've developed some prototype boards over there, which we'll be using in a minute. And we also developed a dashboard. Everything talks to the API, and it's a RESTful API in case any developers want to hear about that.
All right. Not only does this have to be a dynamic solution, because no fire is the same as, I'm sure you clearly know this. Sometimes you might have like a small house fire. All right, you only have 5 firefighters in that scene. Now, not everyone needs to know this. Maybe if it is a small fire, they need to know things like your general fire spread. They need to know your rehab management. They need to know those things on the spot, their vitals. But let's say that we have a much larger situation going on here. Now, if there's a place like the wildfire that we had just a few weeks ago, we have layers that need to happen with that. Multiple teams are going to be dispatched, all of them going one on top of the other. And does each one need to know the vitals of everyone? No, you only need to know your team. And we have a dynamic dashboard that will be adding to that. Once more engines arrive on the scene, they're adding on top of that. And there is one overall person on top of everyone. He doesn't need to know the vitals for each individual person. He needs to know the overall generic, what is the temperature, what is this whole situation going on, what's going on in that forest. Do I need to know the exact vitals? No. Do I need to know the rehab? No. We don't want that to be cluttering their information. We know your time is precious on the field. We know that you don't want to look down and have to sort through information. You need to see that right there and get it done.
So predictive analytics. So what we can do is we gather all this data. Our system already has support for any type of sensor you want to throw at it. Whether that be location, which obviously we're going to test it, temperature, gas, vitals, oxygen intake, whatever it is, we already have support for that. So we can take all of this data and we could give it to Watson. We could give it to whatever predictive analytics system there is. And we can say, how long can this guy survive in a fire? How long can my team survive? What can I do to better my team? Stuff like that. So we have all of this data, and it can easily be exported and sent to Watson or whatever your predictive analytics engine is. This is you.
So in our demonstration today, we have our mock-up, we have the device. This could be something placed on a drone. It is just the Raspberry Pi hooked up to the wireless network with a thermal sensor on it. It could be mounted to a firefighter. Who knows? It's up to you. It's up to the situation to decide that.
So how it currently works is we have an ad hoc network, so nodes can be dynamically added to the network, and it'll just start sending data. So that's what the antenna is on my laptop. We have 2 Raspberry Pis right over here. One right there and one behind this pillar. And let's go ahead and start. Over here. Great. Oh, well, here's a diagram.
Could you tell us what an API is? For those who
Right,
might not
so,
know?
Application programming interface.
Thank you. So an API is application programming interface. It says how can my software hardware talk to your software hardware in a standardized way. So this is a diagram of how it works. We have all of the devices, whatever they are, if they could be drones, firefighters, whatever it is. It uses a RESTful API over HTTP.